大爷，楼上322住的是马冬梅家吧？
马冬什么？
This is the best open-source character motion transfer model, a comprehensive tutorial on SCAIL-2 models, workflows, teaching assets, etc. used in the course. Can be obtained directly in the description. If this course helps you, please give a like and comment. Before learning, please make sure your Python version is between 3.10 and 3.12. At the same time, it is recommended to update your ComfyUI to the latest version. All workflows used in this course are deeply optimized based on the official workflows and use the GGUF series models, which will bring you a better user experience. On the left is the user input area. The upper part is video loading, image loading, prompts and seed settings, and feature toggles. The middle area is the model paths. The top part is LoRa loading and VRAM optimization, and the bottom section is SAM 3.1. On the right is the video generation result. If you want to output long videos, you can enable the extension module on this side. After getting familiar with the workflow, let's start the actual hands-on tutorial. First, load a dancing video. This video defaults to 400 frames. We can set the frame count to use in total frames. 81 frames is a recommended value as it delivers better performance. This time we skip the first 80 frames and clip this middle segment. Next is resolution. SCAIL recommends using 512p and 704p resolutions. It performs best at 704p resolution. If you need a custom resolution, make sure both width and height are divisible by 32. So we use this dedicated SCAIL resolution node. It has these two resolutions preset here. We can also customize it. The resolution from this node will automatically be divisible by 32. Here I choose the optimal 704p, which scales the shortest side to a resolution of 704. Next is the reference image section below. Through this node, we can match the resolution of the reference image to the reference video. Then we upload the image to be used this time. You can right-click to preview it. This is the final output image resolution. Now to achieve this animation effect, we have two options. In option 1, we want the character in our reference image to perform actions completely identical to our reference video. The first option is called motion transfer. In option 2, we replace the character in the reference video with the girl below, using her background and movements. The second option is called character replacement. The toggle for these two modes is here. It is off by default, which uses motion transfer. So let's first learn the simpler motion transfer. Next are the prompts. Because motion transfer uses information from this reference image, and that information is fairly complete, we only need to input the actions. Enter prompt here. Girl is dancing. Random seed. I'll fix it to 1 for now for easier comparison later. The switch below is whether to enable distilled LoRa. When enabled, VRAM load will be lower and generation speed will be faster. This LoRa is pretty much essential to keep on, don't touch it. Then under LoRa and optimization above, we turn off all LoRAs for now. This node reserves cache, which helps prevent out-of-memory errors to an extent. These two are Sage optimization acceleration patches. Then below is a segmentation module used to extract characters separately from the reference video and reference image. This node loads the SAM 3.1 model. The top one is the video prompt, and the bottom one is the image prompt. Our material this time is quite simple, so we only need to input person here. This controls parameter settings. The first is threshold, which controls the strictness of prompt retrieval. Usually leave it at default. The second is max character count. Below that is detection interval in frames. Let's keep default for now. Then right-click and click execute. This character has been successfully extracted. Same for the reference image below. Right-click and execute. The reference character is also successfully extracted. Notice some color differences here. Black parts mean completely discarded, while white parts mean completely kept. And the color information here represents our character ID. We will apply this blue motion pose to our blue character person. Once this step is completed, we can click Q prompt/run. This generation took 234 seconds in total, using an RTX 4090 graphics card. The motion poses here, including gestures and expressions, were reproduced extremely well. Even camera movement changes here were successfully captured. Next, let's step up the difficulty. This time I'll use this asset, and turn off the size adjustment node. This way, output will be made at original resolution. our reference image and reference video have a big difference in resolution. Looking inside our reference image, there isn't just one character, there are many characters in there. Now coming down to the SAM segmentation module below, we keep person unchanged, input max character count as 1, and execute. Every time it executes, it reads both together before generating, which is slow. So consider pulling another node out for tracking preview. Luckily it recognized correctly this time, but actually in many cases, it could easily misidentify, because it might also pick up people in the background. We will explain later how to precisely select a specific character. Then click Run. Even with different resolutions, we correctly obtained the corresponding motion. Look at this comparison. The quality is just as good as before. You can see that SCAIL-2 has exceptional versatility. The reason SCAIL-2 has such great versatility is because the workflow includes a vision model. It performs vision recognition on the reference image, and then inputs it as reference into our workflow. Next, let's swap to another image. We'll use this one. Adjust the resolution. The framing of this reference image is only half body, while our reference video shows full body motion. No problem down here, so let's click Run directly. Even though framings are completely different and there are significant differences in character appearance and actions, it automatically completed the missing lower body parts. Matching actions and camera, no issues either. Next, load this image. She is holding a prop in her hand. This time I want her dancing while holding this bag. So the prompt needs slight modification. The girl is dancing while holding a bag. Let's run and test here too to see if it recognizes correctly. By default, only the character person was recognized. The bag was not recognized. Then click Run. Obviously, the motion matches, but this prop suddenly appears and suddenly disappears. Because a prop's movement involves physics interactions, which is still too hard for current AI. Therefore, it's best for characters not to hold props. Below, let's swap to another reference video and turn off skipping. This is a video with a strong rotating camera movement. Let's test if SCAIL supports such complex camera rotations. Enable the size adjustment node and execute. The prompt here is no longer dancing, fill in the corresponding prompts. Keep these parameters unchanged, then click Run. It does support complex camera reference movements. Even for a large angle rotation shot like this, it handles the matching excellently. Overall speaking, SCAIL-2 is extremely powerful. It adapts to different resolutions and shot framings, recognizes complex camera movements, and can intelligently complete character appearance details. However, its support for extra props is relatively weak. Below, we enable the character replacement LoRa to turn on the character replacement feature. Compared to motion transfer, character replacement has a broader range of application. It is an essential skill for commercial deployment. We use this soccer kicking rotating camera footage. We replace this character with another image material. For material, we use this girl. Turn off the size adjustment node. In this case study, first, our reference shot itself is very challenging. It's a massive degree rotating camera shot, and there are many characters in the scene causing interference. In addition, our material also poses some difficulty. Its resolution and shot framing are both different from our reference video. However, based on our previous tests, rest assured, SCAIL can accomplish this task. Next, let's check the segmentation part. Because there's only one character, the prompt will be simpler. Change to person. We set max count to 1 for both. Run to inspect. Run here as well. In the reference video here, our background is white, so we want to keep the background here. Then the character was successfully extracted. A soccer goal shooting action. For the reference image, the background is black, which should be removed. We only want this character's visual reference. From here we can also see that the final video adopts the reference video's background and the reference image's character. The frame is composed of these two parts, so our prompt should completely describe these two components. Regarding prompts, the official guide has explanations for prompt replacement. Prompts should describe the final screen visual effect after replacement is completed, focusing on the replaced character's appearance features and objects the character contacts or stays close to. Returning to our workflow, we ultimately replace Stephen Chow with this girl, while keeping other video content unchanged. So our focus of description lies in some appearance and visual features of this girl, a soccer kicking action, props like a soccer ball, while background description is less critical, you can consider adding a bit of background description in. Based on our analysis, we can manually type in these prompts we analyzed just now. If you feel it's tedious, that's totally fine. We have a tool. Use a large language model website, taking Google Gemini as an example here. First, upload the prompt instructions prepared for everyone. Then send the video asset and image asset. And input the instruction, enable SCAIL-2 to help me generate prompts meeting the requirements. It might have misidentified here. I emphasize generating prompts here. Then it successfully helped me generate them below. The first is an English version, and the second is a Chinese translation. It described in detail this woman's clothing and appearance, as well as her soccer kicking action, including interaction with the background. However, it misidentified something. It thought both hands were bracing on the ground. We need to manually delete this sentence, along with camera descriptions. For background, there is a simple description here, which works fine. So we copy this string, return to ComfyUI, paste it here, and delete the problematic parts. After all settings are complete, let's click Run, and then compare. Action elements are completely identical. Even for a difficult rotating camera shot, it performs replacement extraordinarily well. Kicking a soccer ball in a dress looks a bit awkward, so let's swap an image. Swap reference image to this one in shorts. This time, resolution and framing of the asset are consistent with our original reference. Using the same method, send video and asset to ask it for matching prompts. Copy and paste this segment, removing its misjudged hands bracing on ground part. Alright, keep seat unchanged, run again. This replacement was also very successful. Where these two videos differ lies in this soccer ball, when our reference image and reference video match in framing and resolution. The soccer ball here performs better. So when choosing assets, try to choose materials consistent with the reference video. Certain details will perform better. Next, let's look at its replacement for talking shots. Upload a new asset.
楼上322住的是马冬梅家吧
110 frames in total. I'll skip the first 29 frames. We replace asset with a man like this. Send the asset over. Copy prompt. Paste prompt over. Then click Run. Let's take a look. Let's look at some details. Drag original video over. When extracting this character, it also extracted this chicken feather on the character's arm. It is white, so in our final output frame, this feather was also retained. Comparing overall again, lip sync matching here has no issues at all. Now let's switch to another case. Let's test if an animal can talk normally. Use this clip asset of the old man. Total frame count is only 47 frames, so no need to skip frames. Our custom set frame count can be set to 0. 0 means using its default frame count entirely. Then replace asset with an animal. This animal is called a capybara, really very cute. However, prompts need corresponding modifications. Send such command again. Check if there are misjudgments. No problem, copy. Paste, run. An issue occurred this time. We need to troubleshoot. Reference video is fine, but this reference image, it covers such a range. Let me redo it. It's likely an issue with our prompt. This time we are using an animal wearing white clothes. Test separately. This time, it corresponds to our reference image. Run again. This time replacement succeeded. Animal replacement and speaking also have no problems at all. When doing multi-character replacement in SCAIL, generally speaking, it's best that our reference image and reference video have the same number of characters to replace. In addition, in the initial frame of reference image and reference video, corresponding character position and height are best kept consistent. Only then can better quality be achieved. Let's first look at two common mistakes. First, reference image resolution differs from reference video. This time we upload this video. Workflow uses motion transfer. It has 300 frames in total. Similarly, we read the first 81 frames first. There are 2 dancing characters here. Uploaded image is a single person image like this. Turn off size adjustment here first. What I want now is, the action this character uses is Stephen Chow's action on the right. These 2 actions look quite similar. Skip the first 40 frames here. Stephen Chow does a rightward movement, making it easy to distinguish. In prompt, we input, this girl is dancing. Next is our character extraction part. There's only one girl, so she's easy to extract. More troublesome is the 2-character video. We connect this data down here, set max character count to 4 first, and prompt is, person. Let's check the effect first. It identified 3 characters here. How do we precisely obtain the character we want? Change max characters to 1. We can precisely describe which character it is, e.g., input, the person on the left side. It's annoying that each output takes so long, so let's set frame count to 1 frame first. This allows quick previewing. Click execute. This successfully extracted the character on the left side. SAM model is very smart. You can write your prompts very freely. For example, you could also write, man holding a green guitar. Copy over and execute. Just like that trick. This time we input, the person holding guitar on the right, to precisely extract the Stephen Chow character on the right. Great, no problem. Next we can change frame count. Back to 81 frames, and click run. Let's look at generation results. The video successfully extracted the character on the right here. The result expands upon our original image background. Motion is indeed present and correct, but a severe problem is, 2 characters appeared here. If reference image and reference video resolutions are inconsistent, it is likely to, intelligently, fill in an extra character. Now look at the second common error, inconsistent reference positions. This time we swap to this character. The resolution aspect ratio is consistent with the above, and the size node is turned on. However, the problem here is, our character's position doesn't correspond to the character position we want to replace. Let's see what happens. Run again this time. In reference video, the character on the right will come out. Indeed, this action rotates to the right. But looking at our result, it referenced the character on the left that we didn't want, rotating to the left. Obviously this is wrong. Why did it rotate to the left like that? Mainly because this character's position was slightly to the left, and left side action was the green guitar holding man's action. So it didn't completely follow our instructions, leaning more towards following spatial location instead. So when doing multi-person replacement, you must keep in mind, positions of replacing character and action performing character should match as closely as possible. Only then can high-quality transfer be generated. Next, let's do a correct demonstration. For 2-person actions, we also try to use 2 characters and match their spatial positions. Here is the first character, here is the second character. Then on position matching, these 2 characters' positions align. Generating like this, it should be fine. The first step is merging 2 images. Here I use Klein's full workflow. I've explained its detailed usage in previous lessons. When using it, still check if the second option is turned on properly. After image loading completes, in prompt I enter, have character 1 and character 2 stand separately in a beautiful place. Background references image 2. For model, I use Black Beast's consistency model. I use a custom 1920 by 1080 resolution. In Lora, turn on this consistency Lora, then click run, yielding an image like this. Replace reference image over. We need 2 characters, so set max characters to 2, and change the character above to 2 as well. Of course, if you only want to replace 1 character, change it to 1, but ensure its position is aligned for it to take effect. Turn off this number. In prompts, remove, on the left side, here. Preview to check effect first. In reference image, background is white and needs retention. The man is blue, corresponding to the blue action on this side. The woman is red, corresponding to the red action here. Click run. This time we successfully transferred both characters' actions over. Next, let's step up difficulty again. We'll use the capybara case from earlier, using character replacement mode to upload, what? This 2-person video. This time, both characters occupy a smaller screen proportion, and for the SCAIL-2 character on the right, his foreground has significant occlusion. We want to replace both characters. Based on what we learned before, we need two characters matching them one-to-one. Use image editing to merge capybara and this man's image together. Send both material segments over, then click Submit. It very smartly performed correct replacement on both characters. Then modify settings here, change max characters to 2 for both. For easier viewing here, we change frame count to 1 frame, and try specifying person for both. Run, these two characters were detected. Now check this side, only one was detected. So I lower threshold strictness to 0.1 strictness. Check again. This time it recognized this capybara as a person. Because strictness is very low, blue corresponds to blue, red corresponds to red, left to right correspondence has no problem at all. Change frame count back to default 0, using all 57 frames, then click Run. Looking here, character on the right succeeded, but character on the left failed to replace. Our character region here was correct. Even after rerolling many seeds, it consistently failed to yield good results. This is because this old man has too few pixels, making character replacement impossible. We must increase his screen area proportion. How to increase screen proportion? At this point, we must resort to workarounds. Original video was like this. Then I cut out the old man separately and enlarged him by 130%. After exporting, reload video, keep everything else unchanged, and click Run again. This time this old man was finally replaced with this capybara. However, the problem is this character is too big, like a giant. Looking at this mask, it indeed did corresponding replacement on red, but this replaced red is our final result. The person is too big. We need a smaller size person. Okay, let's process it again. We upload this image. This character proportion is much smaller than before, compared to our video proportion. The difference is much smaller than before. Running this time, it finally succeeded. From comparison you can see this composition turned out very nice. Let's review the final parameters. Upload this video, then skip the first 14 frames, making total duration 81 frames. Our character positions and sizes. Input prompts to obtain two corresponding characters, thus successfully generating the video. To summarize, we provided 4 character replacement cases in total, 2 common error cases, and 2 challenging correct cases. Actually, the best way to increase character replacement success rate is to edit directly on the first frame of the video. We will have demonstration cases for that later. Our generated video has a big color difference compared to the original reference video. How to make our characters integrate more realistically into our environment is a key question. We will use SCAIL LoRAs to help us achieve this effect. SCAIL is based on the WAN 2.1 model, so it supports WAN 2.1 LoRAs and partially supports WAN 2.2 LoRAs. The official recommended distillation acceleration LoRa and quality enhancement LoRa are essential to keep enabled. Besides those, the main community-approved LoRAs are 2 LoRAs. The first is the PUSA LoRa. It is a LoRa with very comprehensive functionality and compatibility. Generally speaking, it improves video generation quality and adds video generation details. Many workflows in the community have integrated this LoRa. The second LoRa is Relight. This LoRa doesn't have high discussion volume, but it is extremely useful. It allows our character's color to match the background better when composited in the video, as if it were relighted. In my own usage, this LoRa is basically a must-enable. Then on July 15th, the official team released this relighting LoRa, this exact LoRa. Its features are very similar to the Relight we used before. It looks like these two features overlap mainly because when I was preparing the lesson this LoRa hadn't appeared yet. After I finished preparation this LoRa appeared. So I tested it again to compare for everyone later which LoRa is better to use. Let's look at the first PUSA LoRa first. First drag in this video's workflow. Keep seed unchanged. This time, on top of the original base, we only enabled this PUSA LoRa. keeping weight strength at 1.0. Everything else stays the same. Let's compare its effect. Click Run. The noticeable comparison this time lies in our image having much more detail. Taking this frame as an example, debris fragments like these, and these sand grains all appeared. These special effects elements were actually present in the original video itself. After adding this LoRa, details here indeed became better. Additionally, this red scarf aspect was also preserved. Alright, there is a slight difference around the heel here. Judging from this case, it indeed improved picture quality. Now let's compare it with the original video. Then the previous one. So this LoRa can indeed improve our quality in many cases. However, this LoRa also has certain side effects in some situations. Like here, this scarf floated in mid-air, instead causing visual bugs/glitches. Including the heel here, it added some pixels by itself, which might cause deformation. You need to judge based on the situation whether to add this LoRa or not. Next, let's test these two Relight LoRAs. First, look at the 1 series Relight Lora. Keep weight at 1.0. Our case this time is the previous one for this generated video segment. If we look at the character's surroundings, there is clearly a halo of white light. Because our reference character is relatively brighter compared to the reference video, when blended together like this, it is prone to this kind of issue. So let's make an adjustment to it. Drag the workflow in. Keep the parameters unchanged, and just enable this Relight Lora. Click Q prompt. Let's look at the generated result here. There is no longer a ring of white edges around it. Let's compare them again. This relighting effect is very noticeable. And another great thing about this LoRa is that it doesn't add extra details, so it won't ruin our original elements. This is a LoRa you can safely add. Then we'll test the official release of this dedicated Relight Lora. Let's also make a comparison. Left is the original, right is the new version of Relight. Similarly, its color rendering is excellent. Now let's compare these two LoRAs. Left is the old Relight, right is the new Relight. Both of them are effective, but overall, the color on the right looks a bit more comfortable. This side is the original, and this is the new version. The color of the new version is more vibrant. In fact, besides these two relighting LoRAs, the official team also released a color grading node, which is this group here. Let's open it and take a look first. It essentially uses this color matching node to perform color grading. It will take all the output images and, referencing the colors of the first frame of our original video, apply a unified color grading. Previously, I used to enable the old Relight Lora and combine it with the official color grading node to perform color matching. However, since the release of the new Relight, its colors are naturally richer. I recommend using just this Lora standalone. Therefore, I have set this group of color grading nodes to disabled by default. To boost your confidence, I ran another set of tests here. Left has no Lora enabled. Right has the old Relight Lora enabled. The color adjustment of the Relight Lora on the right isn't very noticeable in this set. Left has no Lora added. Right also has no Lora added, but it has color matching enabled. After enabling this color matching, the overall tone resembles the original video more, but it introduces a new problem. The colors will flicker slightly. You'll notice that these colors do suffer from some flickering, causing subtle discrepancies. So, in fact, enabling this official color grading node does come with a slight drawback. For this comparison, left is the old Relight, right is the new Relight. The color on the right is richer, and its color tone is already quite similar to the original video. Basically, keeping only this Relight Lora enabled will suffice. In summary, this Relight Lora is practically a must-have. Color consistency is simply too important. As for this Pusa Lora, it can add a lot of detail to the image. It has both pros and cons, so whether to use it depends on the situation. Currently, for this football video, we've only tested 81 frames. It was originally 169 frames. So how do we generate longer videos? We can use the extension packs on the right. These extension packs are a bit like going to a buffet where you get unlimited refills. Each extension pack provides 81 frames. Its workflow is almost identical to the previous workflow, except it has this reserved frame feature. It takes the last 5 frames generated from the previous segment as a reference for generating the next segment. Subtracting the 5 duplicate frames at the beginning, its effective length is 76 frames. This brings up a question. How many extension packs do we actually need? Below, we have provided a segment calculator. Enter 169 frames here, and then click Q prompt. It shows a total of 3 segments, which means we need 2 extension packs to generate the entire video. So open this extension pack, select the entire block, press Ctrl+C, then Ctrl+Shift+V. Now we have 3 packs. Next, consider the node connections. Here are the steps to follow. First, connect the final output of the previous pack to this input slot. For the third pack, the final output of the second pack is this area after color grading right here. However, as mentioned earlier, this color grading is actually unnecessary, so we can directly bypass it. Skip the color grading, and drag the connection from here directly to this spot instead. Second, parameter adjustment. The parameters for both packs need to be adjusted. The most critical one is the index number. Enter 2 for the second pack, and enter 3 for the third pack. The max object count should match the value on this side, which is the max object count of the split segment. Here, the max object count for the video is 1, and for the image it is also 1, so there's no need to change it. Next is the LoRA adjustment below. This time, we will enable the PUSA LoRA and also enable the new Relight LoRA. So over here, set PUSA LoRA weight to 1 and the new Relight LoRA weight to 1 as well. After filling these in, we adjust the parameters for the third pack, setting both to 1. Then comes step 3. Connect the final output images from both packs into this node for the final merge. This is our final merging node. The second pack is already connected, so we take the final output of the third pack, right here, and connect it to this input. This merges everything generated across all 3 packs together. With that, we've completed the entire workflow setup. If you still feel that this workflow is overly complex, we will introduce a simplified workflow in a later lesson. For now, let's click Q prompt and check the result. This time, it successfully generated the entire duration of the video. Comparing it to the original video again, I think the performance is exceptionally good. And as for the colors, they show minimal difference from the original video. The overall blending is very well done, giving a very realistic feel. Plus, the motion feel of the football and all those visual effects have been preserved. Currently, I don't see any noticeable visual glitches or artifacts. For an open source model, achieving this kind of quality is truly commendable. Next, let's step up the difficulty. This time, we will upload another video, a total of 300 frames, and import all of them. The challenge here is that he performs a body turn like this, then turns back, and there is also a prop thrown toward him. Additionally, there are 2 characters in the scene. Our goal this time is to replace the character on the right side. Based on what we learned previously, for high-quality character replacement, the resolution of our reference image should match as closely as possible, and the scale and position should also be kept as identical as possible. While our reference image only has 1, we need to figure out how to accomplish this type of precise single character replacement. For high difficulty character replacements like this, our highest success rate method is to take a screenshot of the video's first frame, perform an image edit on the target character, and then use that edited image as our reference to generate the video. This technique also applies to our previous case study on Goodbye Mr. Loser. Here, we need to use Klein. Using Klein, I edited this image into this final look. Essentially, I cropped the first frame of this video, and replaced the character on the right with the new character image I had. I used our previous Klein full-featured specialized workflow. Let me quickly walk you through the key challenges of this edit. First, image 1 is a frame capture from the video. I draw a mask around this character, so ultimately, we are only editing this specific region. Image 2 is our target character. The prompt specifies replacing the guitar-playing man in image 1 with the woman in image 2, requiring the pose and posture from image 1 to remain unchanged, the color tone to remain consistent, and emphasizing that the character should blend seamlessly into the environment. It also describes the final composition, a woman standing while playing a black guitar. Actually, this single sentence contains several prompt engineering techniques. First, clearly defining the content to replace. Second, maintaining consistency. Third, ensuring color tones blend harmoniously. Fourth, describing what the final image should look like. Enable the consistency LoRA, then click Q prompt. It will execute the edit on this image. Once edited, it stitches the region back into our original image via this node to obtain the final result. Import the prepared image into the workflow. The total frame count is 300. Calculating the requirement, we need a total of 4 extension packs, quite a few this time. Next are the prompts. Send these 2 assets along with our requirements, and double check if there are any issues. Looks good. Paste them below. Then over here, we need to make sure we isolate and mat out the character on the right side. Slightly modify this prompt. For testing purposes, change the frame count to 1 frame first. This will render faster. Let's see, the male character was successfully extracted. As for the guitar, since it is black, it should be removed. However, our prompt already includes a description of the guitar, so there is no need to worry. For the lower part, setting it to person works fine. Change the frame count back to the full length, or set it to 0. Since the total number of packs is insufficient, duplicate another pack using Ctrl+C, then Ctrl+Shift+V. Following our step-by-step process. First, route our final output to this slot. Second, parameters, change index 3 to 4. The LoRAs are good. Finally, connect the final output of this pack over to here. Once everything is completed, click Q prompt. After a long wait, it successfully generated this time as well. Let's compare the results. The motions are virtually identical, frame for frame. However, this video is not completely flawless. There are still a few minor issues. The most obvious one is the top of the left character's head. Originally, there was a white cap-like item, a wig cap in fact. On the right, the newly generated details made the hair look too real, making it deviate from the original footage. Same with this part, it is clearly a wig, whereas over here it looks like real hair. The cause behind this is still the PUSA LoRA, which autonomously injected extra details. So you'll need to decide for yourselves whether to use the PUSA LoRA or not. We have now covered the core functionality of SCAIL-2. In the next lesson, we will cover SCAIL-2's simplified workflow and multi-image reference features. If this course was helpful to you, please show your support by liking and leaving a comment. Thank you very much.